right, so now we're in week 4. You've got your homework tasks, so we're looking basically at 5E in the textbook. But the class tasks are quite similar. The focus of this week is on completing the square. So the reason for completing the square is to get a quadratic into turning point form, and that's why there's a worksheet here called Revising the Turning Point. Although it wasn't too long ago that we did it, so that should be pretty straightforward. Okay, the next one, transposing a quadratic into turning point form. Okay, so if you haven't looked at the homework video, then you're probably a bit unsure about how to complete the square. So we're going to cover that as well in this video here. So we have our quadratics. You can factorize them as you would normally, but we're going to focus on completing the square today, simply because completing the square, as I said before, puts it into turning point form. When it's in turning point form, you can straight away see what the maximum or the minimum is. And that's going to help you later on when you do modeling questions where, you might be throwing a ball. Actually, I might draw what I am talking about. So let's say we were throwing a ball and you wanted to know how high it was. If you had the quadratic, if you put it into turning point form, you can straight away see what that height would be. Otherwise, there are other ways you can do it, but turning point form is a great way of seeing the features of a quadratic, especially the turning point. Okay, so the first one, we've got y equals x squared plus 6x plus 5. So you're probably thinking, well, I can easily do that by, two numbers when multiplied give me 5 and when added give me 6. Oh, there it is, miss. I've factorized it. Now, there's nothing wrong with this, but you can't see what the turning point is. So what we're going to do is put it into turning point form. So in turning point form, what we do is we have y equals x squared plus 6x. So we look at the first two terms. And I'm just going to change the color because this is something that is slightly different. So we're now adding whatever this number is here. So in this case, it's 6. And we're going to divide it by 2 and then square it. Okay, so this is the process of completing the square. Now, because we've added something, we then have to also take it away. Otherwise, we're basically changing the quadratic. So if we don't take it away, we've changed the quadratic. But it's the same as saying, well, if I added 2 and then I took away 2, I'm not changing anything because effectively I haven't added anything because whatever I added, I've then taken away. Now, actually I might do this in green. Don't forget we've still got the plus 5 on the end. Okay, so let's go back. I'm going to do the rest in blue because I like colour. Okay, so we've got now y equals x squared plus 6x, and I'm just going to tidy up these bits here. Now 6 divided by 2 is 3, then 3 squared is 9. This is the same thing, so I can just do take away 9 plus 5 on the end. The reason we do that is I can now factorize this. So I have y equals, and it's to get a perfect square, so this will become a perfect square. And the number that you plus, or if it's a negative, you take it away, is whatever you have in the bracket. So 6 divided by 2 is 3. And when you think about it, x plus 3 times x plus 3 will give you this expression. And if you don't believe me, you can go ahead and expand it if you like. Okay, minus 9 plus 5 is now minus 4. So can you see how you now have the quadratic in turning point form? So you can straight away see that your turning point is -3, -4. You can go on and do the difference of perfect squares for this one because of this minus sign. So you can go on to do the difference of perfect squares to get your x-intercepts. And I'm just thinking what else you could do. Actually, difference of perfect squares will give you what we have up here. Anyway, and then you could get your x-intercepts, or you can just get your x-intercept by letting it equal 0. But at this point, I'm sorry to ramble on, but I'm just thinking of what you can do going forward. But the important thing here is getting your equation in turning point form. Okay, and then you can see what your turning point is. All right, let's do the next one. Okay, so we're just going to focus on completing the square. All right, so I won't do any of that other business. So let's do question B. Y equals x squared plus 6x. Now, this is where we complete the square. So we add 6 divided by 2 squared, and then we take away 6 divided by 2 squared. And what I should have done before is did the plus 2. Okay, so the only thing we've introduced here is the green part, but as you can see, we're adding it and then we're taking it away. So we're not changing the quadratic at all. All right, now we're writing the first 3 terms. 6 divided by 2 is 3. 3 squared is 9. And then we have minus 9 plus 2. So I'm just going to factorize this. Now it becomes a perfect square. It will always be a perfect square. That's the reason why it's called completing the square. So we got x plus 3 squared. Remember, this 3 comes from whatever you get in the bracket here. Minus 9 plus 2 gives you minus 7. So again, you can see what your turning point is. All right, I might skip C and D. See if you can do C and D on your own. And I'm going to do E. So E, we have y equals x squared minus 4x plus 14. Whoops. Oh, I've rewritten it. It's okay. So remember, we take the coefficient of x, put it in brackets, so negative 4 over 2 squared. Then we take it away. And then we add the 14 on the end. So I didn't do different colours there, but hopefully you can see now what I am doing. Just before we move on, it's important to bring that negative over. So you might be thinking, well, it doesn't matter because I'm squaring it anyway and I get a positive number. That is true. But when you do your perfect square, because you've got a negative here, this number in here would become a negative also. I'll show you what I mean in a sec. So we have x squared minus 4x. Negative 4 divided by 2 is negative 2. Then negative 2 squared is positive 4. And we've got to take away 4 and plus 14. Now, these first 3 terms become a perfect square. This number in here, which is negative 2. Okay, so remember that it had to be a negative. So that negative has to follow to here because that has to be a negative here. And when you think about it, 2 numbers that multiply to give you 4. So negative 2 times negative 2 give you positive 4. And 2 numbers have to add together to give you negative 4. So negative 2 minus 2 is negative 4. And then negative 4 plus 14 gives you positive 10. Now this quadratic, I can see that the turning point is at 210. I also know it's a positive parabola that's been shifted up 10, so it doesn't have any x-intercept. So I can't actually factorize this any further using the difference of perfect squares. So remember, you have to have a minus in here to be able to factorize it any further. So we've completed the square and we can't actually factorize it any further. All right, I'm not going to bother doing question F. And I'll show you in a sec how you can do all that on your calculator so you can check your answers. Now, question 2, complete the following table without using your CAS. Once you have completed each row, check that you are correct by checking your answer on CAS. Okay, so let's do one that we haven't done. They're all positive parabolas, so they're all going to have a minimum turning point. But anyway, let's have a look at, oh, we did all this, didn't we? Okay, we'll do F. Sorry, I'm thinking aloud. So we have y equals x squared minus 12x. I'm going to do all this in one go. I'll rewrite the equation again. and then we've got minus 5 on the end. So x squared minus 12x. Now you don't have to do this either. Some people will be able to say straight away, all right, negative 12 divided by 2 is negative 6. Negative 6 is, squared is 36. So for some people, they, don't have to write it like this. And you'll eventually get there too if you haven't already started doing it. All right, so now we have x, remember this is minus 6 squared, and then negative 36 minus 5 gives me negative 41. All right, so my equation, I did F, I'm not going to bother writing it out. It's a minimum, okay, and it's a minimum because it's a positive parabola. It looks like this, okay? Minimum is down the bottom, maximum is at the top. The coordinates of your turning point are H, K, so H is 6 and K is negative 41. That's going to be a pain in the bum to sketch, but there it is anyway. We just basically say that's the point. Hold on, no, sorry, just thinking aloud. Negative 41. If you wanted to do a rough sketch, you should really find the x-intercepts and the y-intercept as well. I'm not going to do that for this one. I'll show you on CAS. So we're just looking at the turning point here. Now, if I get my calculator open, I might have to reopen it because, all right, sorry, I just had to get the calculator up and running again. All right, so in your menu, all you want to do is add a calculator. It's probably the easiest way. You can graph them, but you can also complete the square on your calculator. So I want to show you that now. Go to algebra, then complete the square. So if we're doing f, you don't have to put y equals, just write the expression on the right hand side, minus 12x minus 5, and then do comma x, and it'll put it into turning point form for you, which is really nice. So you can see there that I actually got the right answer. Woohoo! I'm also want to show you something else that may be of interest to you. So you can do it that way, but you can also, if you go to calculus, it will find the minimum or the maximum for you. So for this one, I know it's a minimum because it's a positive parabola. So I'll just type the expression again. So not the equation, just the expression. And we're going to do comma x because that's our variable. And you get x equals 6. Now, you can get the calculator to substitute this in if you like. So if I'm thinking on the spot here actually. So let's just get rid of all that. So there's our expression. Okay, x squared minus 12x minus 5. And then you can tell it, all right, I want you to calculate that when x equals 6. And there's your negative 41. So this line here means given that. So if you go control equals, you can find it there. So basically you're telling the calculator to substitute in this value for you. So it's another way that you can kind of get your turning point. So you can do complete the square and read it from here, or you can do F minimum from the calculus menu, okay, function minimum, maximum if it's a negative parabola, and then you can get the y coordinate by substituting 6 back in. Another thing you should know, if you haven't already realized, is you can solve equations. So if we were finding the x-intercepts, okay, so there's our expression, we let y equal 0, and there's our x-intercept. So my calculator is set on exact mode, but if you want to get decimal answers, just press Control Enter, and you'll get your decimal answers there. Your y-intercept, you can read straight from the equation, so it's negative 5. So remember, your constant in your expanded expression will always be your y-intercept. Okay, I know I'm probably going off track here, but there's so much that your calculator can do, and I know a lot of you are scared of calculators, but basically if you ever think I think my calculator can do this, the answer is probably can. You just need to figure it out. So there's our equation, and what I've seen in the past, a lot of students just draw that line and think it's, well, I don't think they think it's a linear equation, I just don't think they think at all about what it should look like. It's a parabola, okay? It's a parabola because we've got the x squared. So that means you need to change your window. Now we worked out before that your turning point was at 6, -41. So that means my y minimum, has to be, let's do -45. And let's just make this one a little bit bigger too. So I might make that 15. We should be able to see everything now. Okay, so you can see your turning point, your x-intercepts, and your y-intercept there. So you can clearly see it. All right, please make sure you are confident with your calculator. There is so much that you need to be able to do on your calculator. Don't just rely on doing everything by hand, but also don't just rely on using your calculator and not doing it by hand. So for these other ones, there's no answers, and I did that on purpose because I want you to be able to check your answers on your calculator. All right, I'm going a bit over time, so good luck and ask for help if you need it. Bye-bye.